All right, good morning, everyone. So, today is Monday, June 16th. Day 9 for Math 133. We are got a couple things to do today. Chapter 5 review and our third cumulative review worksheet. So, this is our last cumulative review. Um, and so, those are the two things we're going to be covering today. Uh, Before Wednesday, you'll want to watch 6.1. Chapter 6 is on the midterm, so you are definitely going to want to make sure you do those lecture notes. Next Wednesday, I will be gone, but Elaine is going to cover the Chapter 6 review. Okay. Um, on Monday next week, we have a sample midterm. Now, the sample midterm is pretty large. Okay, it's larger than the normal midterm. Okay, and it is worth points, so you're going to want to make sure you turn it in. But I'm bringing it up now because you're probably gonna want to get started on it sooner. It's not going to be something you're going to want to wait until Tuesday night or to try to finish or Wednesday. Um, First of all, because it's big, okay? So if you guys have any time on Wednesday, after you finish the chapter 6 review, I would definitely recommend jumping in and starting looking at the sample midterm, okay? And then the other reason why is because it's going to help you prepare for the actual midterm, which is on Wednesday, June 25th. So uh, I have a uh, proctoring instructions information about the midterm exam, which I'm going to be dropping in Remind right after this class. So make sure you take a look at that. Bring any questions you have to us and make sure you're ready to go. Okay. So I'll be dropping that into Remind in a little bit here. Um, After the midterm is over, we're going to do the chapter 7 review. I still haven't rearranged everything there yet, but that's where we're at. Um, so for today, though, chapter 5 and the cumulative review worksheet, which will go up through chapter 5. Okay. So lots of chapter 5 stuff today. Um, And just like usual with our worksheets, I'll give you some hints on most of them, and then I'll stop the recording. And for everyone who's still in the class, we'll work on the worksheets and make sure we get those wrapped up. Okay. Uh, yeah, so that's your reward for coming to class is we work on the worksheets. So everyone can watch the video for the hints, but I don't know if you like the hints more or if you prefer to just get the whole worksheet done. I like getting the whole worksheet done. So thank you for coming to class. If you haven't finished the chapter 4 review or the cumulative review from last Wednesday, you still have time to turn that in today. Um, let's jump in. Um, Chapter 5 review is on page 350 in your course pack. And once again, I'll ask, put your name on it, please. It really does help me. Um, so there we go. Page 350 in your course pack. While you're at it, you can pull out starting on page 381 is where the cumulative review, which we're going to cover as well in a little bit here. Page 350, chapter 5 review worksheet is all about probability. Okay. So how likely certain things are to happen. Okay. Um, so when we talk about probability, we talk about whether things are disjoint or not. Okay. Sometimes you might hear it not referred to as disjoint. You might hear it referred to as mutually exclusive. So that just means so disjoint means uh, that something cannot both happen at the same time. Yeah, room. Okay. That's disjoint. Okay. Not disjoint means it can happen. Yeah. At the same time. Okay. So for question number one, a red die and a blue die are rolled. Can a red die come up two and a blue die come up three? Can both of those happen at the same time? Yeah, you can have a red two and a blue three, right? If you roll one red die, you can't have a red that ends up as a two and a red that ends up as a three because you only rolled one red die. But so this one would be not disjoint. They can happen at the same time. Okay. Um, all right. Most of this, most of this we'll work on together. Uh, I'll give you a hint on number three. Uh, there's three answers for number three, and I want you to circle all three of them. Okay. So there's your hint for that one. Uh, all right, let's move on to page 351. Page 350 is really no problem. You guys can handle that one without too much difficulty. Page 351, I'll give you a little more help. So, um, probability experiment involves tossing a three-sided die, so a D3. So, recording the result of a one, two, or three, and then spinning a wheel. So use the multiplication rule. Okay. How large is the sample space? Okay. So when you do the multiplication rule, you'll take the first probability, or sorry, the first number of outcomes times the second number of outcomes. Okay. And that gives you your total number of outcomes. Okay. When we talk about outcomes in probability, we're talking about the possible results, right? We're talking about the sample space. So, in other words, like what could happen, okay? And when we talk about outcomes, we count them up. So, rolling a d6, if I rolled a six-sided die, there's six possibilities. So I have six outcomes, okay? Here, I have two different things that are happening. So I take how many outcomes there are for the first, how many possible outcomes there are for the second, multiply those, and that gives me my total. Okay. All right. So for part B, create a tree diagram. That's one of these guys, right? So if I roll my dice, I might get a one, a two, or a three. Okay. And then for each of those results, I got a little tree right here that says, it could be red, could be yellow, could be purple. Okay. So this first one here, 1R, is I rolled a one and I pulled out, or I spun a red. Okay. One Y and so on. Okay. That's the tree diagram. The sample space, the number of things you have in your sample space, should be the same as this total number of outcomes you have up here. Okay. That's what the outcomes are doing. They're counting the sample space. All right. Explain what P2R means in English with context. Okay. Actually, I'm not gonna give you a hint on that one. You guys can do that. Oh, this is a typo right here. Um, right here for part E. This should be D. To calculate part D, you had to assume blah blah blah. Okay. Um, compute the probability of having a die roll of at least two. At least two means two or more. Okay. Of it spitting purple. Yeah. Okay. I think you guys got this. I think I'm going to move on to page 352. Okay. Most people don't have too much difficulty with chapter 5, so not giving you as many hits. Sorry. Um, all right. Uh, this table shows the number in thousands of earned degrees by level in two different fields conferred in the U.S. in recent years. So natural science and computer science. Um, this, if we go back to Canvas and click on Chapter 5 review worksheet, it's going to bring you here. And then if you click on this link, it'll bring you here. And so this is the same data in a Google Sheet that we'll have on the paper for uh, chapter 5. So if you need to do anything in Google Sheet, like add them up or anything like that. Okay. Um, all right. So when we're doing probability is a ratio. It's the number of wanted outcomes on the top divided by the total number of outcomes in the bottom. Okay. The total number of outcomes is this guy right here. Okay. So you have 199 total for natural science. These, by the way, these are measured in thousands. So it's not actually 199 people, zero point 0.1 people, because you can't have zero point 0.1 people or zero point 0.1 degrees, right? This is actually 199,000, comma 100. Okay. But that's okay. We'll just keep our units in mind, okay? But we're going to divide by this total here, okay, which is 447.4. So I had 199 people for natural science, 248 for computer science. So I have 144, or sorry, 447,000 people for my total, okay? Um, all right, so the explanation for all of this on how to do all these, if you need, is on page 132 and 133 in your course pack. Okay. Um, Science degree, disjoint, not disjoint. We talked about that. So disjoint means that they cannot happen at the same time. Earned a doctoral degree, and so this is overlap. This is asking where they overlap. Okay. So in other words, I have, my table here where I have my rows of bachelor's, master's, doctorate, natural science, computer science. This is asking where those two things overlap, okay? Because it's an and. Here, with an or, there's a formula for this, okay? For an or, we need to find the probability of a master's plus probability of computer science, and then we have to subtract the overlap, okay? Oh, can't parenthesis. Okay. So when you're doing an and, it's just the probability of both. Okay. What's the probability that both these things happen at the same time? Okay. When you're doing an or, you add up all the masters, all the computer science, but then you have to subtract the probability of both. Because if you don't subtract the probability of both, you're double counting them. Okay. All right. Um, oh, another typo. For part H, would any of the events A through G, A through E, be considered unusual? Okay. All right. The last page for this one is page 353. So for this one, um, we have line probability distribution. Oh, actually, this is not page. This is question number 6. It doesn't matter. A lot of typos on this one. Sorry, guys. Uh, Following probability distribution was created by Cascades Human Society. So how many dogs? What's the probability? Explain what must be true in order for this to be a valid probability model. So we talk about probability models on page 118 or page 137. Um, so there's two explanations. So there you go. Um, let me see. Okay. Uh, just jumping around a bit. If a single Jackson household is chosen at random, what is the probability that has an odd number of dogs? So you guys know what odd means, right? So one, three, five. So it'd be these ones, these ones, and these ones. Okay. You don't need, yeah. If a single Jackson household is chosen at random, what's the probability that it has at least two dogs? That's two or more, right? So then two or more would be these ones here. Two, three, four, five. Okay. All right. I think that's pretty easy. I think you guys got that. So, um, before we break up into, well, I guess we're not going to break up into groups. We have only a couple people, but uh, we do have another worksheet to talk about, which is the cumulative review worksheet. So I want to give you some hints on that before I, uh, yeah, before we move on. Um, so this is chapters 1 through 5. Chapter 6, we'll work on Wednesday. Uh, my name on this. So if I go to Canvas and I click on the cumulative review worksheet, number 3, if I click on this, there'll be a link to the data set in StatCrunch. So make sure you sign in, and then you'll be able to do, your summary stats column, right? So that you can get uh, all of all of these numbers filled in very quickly, right? So you don't have to sit here and, and do the formulas. We're not doing that. Uh, so this is so to get a mean and a standard deviation, um, on page 231, or sorry, page 232. On page 232, we had a couple of different methods depending on whether I have raw data or whether I have a frequency distribution. So this would be raw data. It's the actual numbers. So we're going to use method 1. Okay. Um, and uh, here I've got a bunch of symbols. So we talked about these symbols in one of our worksheets before. So the place that you'll find some of these symbols, you can find symbols so you know what they all mean. If you've forgotten, is page 5, 61, 68, and 83. Okay. Um, so for example, here we have lowercase n. Lowercase n is your sample size. You remember that capital N is your population size, right? Because a population is larger, the sample is smaller. Okay. Um, let's see. Uh, are the values above parameters or statistics? Uh, that was on page 7. So a parameter is for a population. A statistic is for a sample. Okay. Fences, the formula for that was on page 84. And if you don't have that memorized, that's a good equation to put on your uh, 8.5 by 11 piece of paper, right? You're allowed to write out um, whatever you want on an 8.5 by 11 piece of paper, front and back, for the exam. And you're allowed to bring that to the exam. So any formulas or any instructions on what do I click on in StatCrunch, things like that. Okay. What's the shape of this distribution? Uh, find that on page 87. Um, Michigan had an obesity level 35.2%. What's Michigan's Z-score? So formula for that is also in our yellow packet, right? Page 231, right? Z-score is how many standard deviations. It's uh, counting how many standard deviations Michigan is away from the mean. Um, if it's exactly on the mean, then it's a 0, okay? And we consider anything that's uh, past 2, so either greater than 2 or less than -2, we consider that unusual, right? So does Michigan have an unusual obesity level? You'll find that on page 80, okay? So if your z-score, if your standard deviation count, if your z-score is between 2 and -2, so it's a very small number, then no, it's not unusual. Page 382, this scatter plot shows the relationship between the U.S. state's annual alcohol consumption and its annual drug overdose deaths. So our units here are in thousands of gallons of alcohol. Holy smokes. Um, uh, so this is the result of all of the StatCrunch stuff. So they did the StatCrunch stuff for us. That's great, right? So if you, we're going to do a linear regression. All of our regression information was on page 233, right? That was all the chapter 4 stuff. There was a whole bunch of stuff on that page that we used, on interpreting things and like how to, you know, uh, how to calculate a bunch of stuff. So our dependent variable is y, and our independent variable is x. Okay, so I kind of got those flipped around. Dependent is always y. So our y values are here, x values are here. Okay. Um, all right, Michigan has a point on the graph somewhere in here at the coordinates uh 19,860, comma 2385. Explain what this means for Michigan. So there's not really a script here for this. This is basically just saying Michigan had 19,860 something something and 2,385 units. Okay. So all it means is just, fill in this. What's the strength of the linear relationship between the two variables? So on page 233, we look at the R value, right? And if your R falls along on page 233, we had a number line that would indicate what we would call it, depending on where R lands, okay? Um, what's the regression equation? So the regression equation is y hat equals blah, 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 right? So it's mx plus b or ax plus b. So fill that in. Um, what's the slope? Interpret the slope. So interpreting the slope, there was a script for that on page 233, right? It's like if your x increases by 1 unit, then your y increases or decreases by 1 unit, right? What's the y-intercept? Remember that a y-intercept always has 0 comma something, 0 comma a number. Okay. All right. Let's move on to the next page. The following shows type of health insurance coverage and race ethnicity for a random sample of people in the US. So this is random group. I said random sample. This is a sample though. Okay, so we're looking at a sample population, not the whole US. Okay. Um, so the column variable, column is up and down, so that would be uh the type of insurance, right? And then the row variable is race or ethnicity. Okay. So when we say column variable, I don't want you to just look at this column and say, oh, these are all races, okay, in this column. No, what that means is each of these columns represents something. What does each column represent? Each column is a type of insurance. Each row represents a race. This is the white row. This is the black row. Okay. Explain why researchers cannot conduct a designed experiment to obtain data on these variables and their relationship. So, in order to do a designed experiment, okay, you need to be able to do random assignment, okay? So, well, why can't we? I mean, you can do a random sample. This is a random sample, but why can't we do a random assignment? Well, you can't take each person and randomly assign them a race. Each person already has a race. You also can't really randomly assign someone the type of insurance that they're eligible for, right? You can't just be like, okay, you've been selected for this study, you're going to have Medicaid. Well, no, I mean, everyone who comes into the study already has insurance and you have to, certain qualifications in order to be, part of Medicaid and so on. So it's impossible to randomly assign race as well as insurance. Okay. Yeah, you can't do that. So, what was the sample? So the sample here was a random group of people, right? Random group of people in the US. Okay. Um, what's the sample size? What's the population? So the population is related to the sample. The population is uh, all people in the US, right? Um, that's fine. Uh, okay. Uh, it's unusual to be uninsured. Okay, is it unusual to be uninsured in the US? Use probability to explain. So in order to tell that, we need to do the probability of uh, uninsured. So calculate the probability of uninsured. And then what do we consider unusual for probability? Okay. All right. Probabilities found in this table will be what? So we talked about this on page 120, what these three different means. So for classical, it's logic or theory. Okay. Empirical is from data, and subjective is just made up, which doesn't mean that it's useless. Okay. It's made up from nothing, but subjective probabilities still have some value. Okay. All right. One more page, and then we'll start doing some math together. All right. That's the exciting part, right? Um, all right. So we're still talking about the same thing we were looking at a second ago. People insured by race. You're going to select a single random person in the US using the two-way table, find the probability that, uh, and we're make sure you give four decimal places for all answers. Okay. So pay attention to the number of decimals that we're looking for. But when we do probability, we are going to divide by the big total. Okay. It's very rare that we're going to do conditional probability, which is where you divide by a different total. Usually you want to divide by the total number of outcomes all together. And that's the big total. Okay. That was the that was this guy. This is our big total, 10,054. Um, okay. Remember what and means in probability versus or. Okay. And we want the probability of both, or we have to do there's a little bit more work with the or. Talked about disjoint. That means they can't, or sorry, yeah, disjoint means they can't overlap. They cannot. Not disjoint means they are allowed to overlap. Okay. Here's another or. Okay. So that's right. We had a bit of a formula for that, right? Okay. Um, I think that's all I've got. Um, so yeah, I'll be sending out this information, not this guy. I'll be sending out this information about the midterm that's coming up in just a few minutes. Um, so today we're covering two worksheets, right? Chapter 5 and the cumulative review. Both of those have 4 pages, so we're looking at a total of 8 pages. The midterm is 9 pages. Okay. So if you're feeling like, okay, I have no idea how much time I'm going to take, um, look at how long it takes us to go through these two worksheets, and then add another page. So it's not too bad. Most everyone is going to be able to finish the midterm in 2 hours. Our time slot is 3 hours, if you're taking it with me. If you feel like, okay, I'm going to need more time, then you'll want to take it at the testing center. Okay. But it's 9 pages versus the sample midterm, which we already mentioned. Sample midterm is going to be much larger. Okay. So we'll give you more chances to review. But all right, I'm going to stop my screen share and I'm going to stop the recording and we're going to work on some worksheets.